All right, so there's 4 possible outcomes in a hypothesis test, okay? And notice these are all about the null. So whenever you make your decision, it's always about the null. And that's what I call these. I call these 2 things the decision, either fail to reject or reject. So you'll hear me say, state the decision and then state your conclusion, and I'll show you what that is later on in the notes today. But when I say decision, I mean these 2 things, okay? So the decision, fail to reject the null. If the null is true and we fail to reject it, that's good. That's called a type A correct decision, okay? So the null is true, we failed to reject it, that's a good thing. If the null is true, but we reject it, that's bad. That's called a type 1 error, okay? So the null is true, but you reject it, meaning you prove that it's not true, or you think you've proved that it's not true, then that's called a type 1 error. The null is false, but you fail to reject, that's called a type 2 error. And the way I remember that, the null is false, but you fail to reject, there's 2 F's. That's how I remember that one. Okay? And I learned in high school, and then it really helped me in college. However, I could come up with ways to help myself remember things. It was very helpful. You know what I mean? So, type 2 error is F with F, 2 F's. So, the null is false, but you fail to reject it. That's not good. If it's false, we should be rejecting it, right? And that's what we have here, which is the type B correct decision. So the null is false, and then we reject it. That's called a type B correct decision. Okay? So 4 possible outcomes. So remember that detergent example we did Tuesday? We wrote the brand name does not outperform the store brand. For our null, and our alternative was the brand name outperforms the store brand. Remember that? Same meaning here. There is no difference. The brand name outperforms or performs better than the store brand. So here are our 4 possible outcomes given with the statements themselves. So the null is true, and we fail to reject it. That's a good thing, right? So there is no difference between the detergents, because that's the null, so that's true. And we conclude that there was no difference. So the action would be the consumer bought the cheaper detergent, saving money and getting the same results. Okay? The type 2 error would be that the null is false. So if the null is false, the brand name does perform better, right? The conclusion, though, if we found it's false but we fail to reject it, we would conclude that there was no difference. So the action would be the consumer bought the cheaper detergent, saving money, but then they would get inferior results. I know there's a lot of words on the screen, but are you understanding? You are? Okay, good. So the null is true, meaning there is no difference, and we rejected it. So our conclusion would be that the brand name detergent was better. Even though there isn't a difference, we would conclude it, right? Because we would reject it. So the action, the consumer bought the brand name detergent, spending extra money to attain no better results. And the last one, the null is false, and we reject it. That's good. So the brand name detergent is better. We determined that it was better. The consumer bought the brand name, spending more, but getting a better result. Questions? So it's important to be able to go from this and write the 4 possible outcomes and understand, what's going on. And I will tell you, I have a hard time remembering which one's A, which one's B, which one's type 1, which one's type 2. Type 2, I got the F with F, but, so I have to think about all that. So I'll show you in a little bit. I literally write it every time, my 4 little hints for myself, and then right below them, I fill in using the null and the alternative, okay? All right, the probability with which decisions occur. If we fail to reject when it's true, this is the correct decision, and the probability of that occurring is 1 minus alpha. Does that look familiar to you? Haven't we been working with 1 minus alpha? What do we call that? Not error, not standard error. Isn't that our level of confidence? LOC? If we want to be 95% confident, then that means alpha is 0.05, right? Remember that? So that's our confidence level. And that's a correct decision. So isn't that what we want? Don't we want to make a correct decision? Okay, so notice alpha is the probability, right? So before, I would say use a 95% level of confidence. Remember what I would say that? And I taught you, if that's your level of confidence, then how do you find alpha? You just do 1 minus that, right? Okay, so what would alpha be if it's a 95%? 0.05. Well, now you know what that means. What does the probability equal to 0.05 mean? It's the probability of you committing a type 1 error. Okay? That's why alpha is so important. So you want to keep your level of confidence high so that your alpha stays low, or vice versa. You want to set your alpha low, really small, right? So that your probability of making a type 1 error is less. All right? This is B, beta, in the Greek alphabet, beta. And beta is the probability of making a type 2 error. Okay? And then if you make a correct decision, the probability of that happening is 1 minus beta. We actually aren't going to work with beta really much, okay? But it's still important to know that beta is the probability of making a type 2 error, okay? So alpha is the probability of making a type 1 error. Beta is the probability of making a type 2 error. 1 minus alpha, which is our level of confidence or our confidence level, that's the type A correct decision, and then 1 minus beta is the type B correct decision. B, beta, A, alpha. It should make sense in your brains, right? A is alpha in the Greek alphabet. Okay. So I have an example. A calculator company has just received a large shipment of parts that are used to make the screens on graphing calculators. They consider the shipment to be acceptable if the proportion of defective parts is 0.01 or less. If the proportion of defective parts is greater than 0.01, then the shipment is unacceptable and returned to the manufacturer. So state the null and alternative. Do you remember what I said to you the other day when we're using math symbols? I told you it was actually easier. Very good, Caitlin. The equal to always has to go in the null. Okay? So if you read this, the shipment is acceptable if the proportion of defective parts is means equals, or less. So we are going to have to use another symbol too, though. The proportion is P, because that's just a fraction, right? So P is less than or equal to 0.01. Do you see how the equal to is in that one? So it's fine that we put less than or equal to. The main thing is don't just put less than and put greater than here, because the equal to is what we're looking for. That always goes in the null, okay? So then this one would be the proportion is greater than 0.01. And because I always try to help myself out, y'all are super, super smart. And I'm not being facetious when I say that. I genuinely mean it. I, though, just have to give myself little helpful hints. So what I like to do is, in parentheses, write, okay, so if the proportion is less than or equal to 0.01, what does that mean? The shipment is acceptable. So I would put that for myself just because it helps me not have to go back up into the problem every time, you know. So if the proportion is greater than 0.01, it's unacceptable. Okay. So now we're going to describe the 4 possible outcomes and then the resulting actions. Okay? So what I was saying to you a while ago, this is what I do for myself. I write what type A is, and then I leave some room so I can write what the actual results are, right? And then I write what type B decision is, type 1 error, and type 2 error. So a type A decision is when the null is true and we fail to reject it. That's a good thing. A type B decision, the null is false and we reject it. That's good, right? A type 1 error is actually harder to talk about. So let's go to type 2. Do you remember what I told you for type 2? 2F's, good. So the null is false and we fail to reject. So then this one would be the null is true, but we reject it. Something I noticed, do you see how it's true, false, false? And here it's fail, reject, reject, fail. So just some things to help me out because I always put them in the same order every time. A, B, 1, 2. So true, false, fail, reject, reject, fail. You know what I mean? I hope that didn't just confuse you, but I have to come up with ways to help myself out because I just can't remember everything. You know what I mean? Okay, so type A decision, the null is true. Well, let's look at the null. P is less than or equal to 0.01. Now, you can't just put P is less than or equal to 0.01. You got to write in words. What does that actually mean? Because if I'm sitting in your audience, maybe I don't understand the math symbols, right? Now, you would have those, but once you're writing your conclusion, you have to put it back into terms of the problem itself. So what does this mean? It means the proportion of defective parts is less than or equal to 0.01, right? So is 0.01 or less. All right, so that's this first part. H sub O is true, the null is true, and we failed to reject. So what does that mean? We failed to reject it. We didn't reject this, right? So that means the shipment is? Yep, the shipment is found to be acceptable. Okay. So this one, the null is false. So if the null is false, it means this one is what we're going with, right? Because this one's not right. So the proportion of defective parts is what? Yep, very good. Greater than. Okay, so what would we conclude? It says it's false and we reject it. That's good. So if I reject it, I'm rejecting this. So that's kind of like scratching it out, right? So if I reject that, what does that mean? Yeah, it's unacceptable. So the shipment is found to be unacceptable. Aren't those both good situations? for us to be in. The proportion's less than 0.01, we found it to be acceptable. That's good, right? Or the proportion of defective parts is greater than 0.01, and we found the shipment to be unacceptable. That's also good. Now we're going to talk about the type 1 and type 2 error. And type 1, remember, this is alpha, so the probability of making a type 1 error. So that's what we always try to keep really small when we're solving these problems, right? So what would that mean? Okay, the null is true, so the proportion, you help me, the proportion what? Is 0.01 or less. Good. All right. But we reject that. So what does that mean? The shipment what? I'm sorry? Is found to be unacceptable. Ooh, that's not good, is it? It meets the requirements, but we find that it's not acceptable, so we send it back. Okay. Or the next one, H sub O is false, the null is false. So that would be the proportion of defective parts what? Is greater than 0.01. And the shipment what? But we failed to reject. So yeah, the shipment is found to be acceptable. Uh-oh. That is not good. You know, if you're the calculator company, which would be worse for you, the type 1 error or the type 2? If you're the calculator company. 2. Yeah, the proportion's greater than that, but you accept it anyway, so then you're stuck with all these messed up parts, right? If you are the shipping company that's making the parts, which one's worse for you? Type 1. Right? Because the shipment's okay, but they reject it. They send it back. They say it's not acceptable, right? Okay, so just be aware of your 4 different possible outcomes, right? And then, you know, sometimes people are like, oh, the type 1 error's worse, always worse, always worse. I think it really depends on who is invested in it, right? So on that example, that's why I had you break it down. Which one's worse for the graphing calculator company? Which one's worse for the shipping company? Okay. All right, this is why I wanted to get to this last week. But then, you know, I was out sick Thursday, and then Tuesday we just didn't get to it. Because look, it's about the Super Bowl. Come on. Super Bowl was Sunday. So your friend is having a party, and you have been invited. Your decision will be to attend or not to attend. So you want to go only if you can be convinced that the party is more fun than his typical party. Okay, with the watch, right? Stay on focus. You do not want to go if the party is going to be just another dud. All right, so typical parties are not fun. You're only going to go if you can be convinced that it's going to be more fun. All right, so your position is that the party will be a dud, and you're not going unless you can be convinced otherwise. So the basic idea of the hypothesis test is evidence disproves the null hypothesis. So you're thinking it's going to be a dud, so that would be your null. If you disprove that, it means you'll go. Okay? So the party will be a dud is your null, the party will be a great time is the alternative. So we're going to write the 4 possible decisions, and that's on the next page. I gave you room for that, okay? Okay, so what do I do to help myself out? Good. A, B, 1, 2. That's right. Very good. Okay. So A is, the null is, do you remember my hint? true, false, right? So the null is true. This one is the null is false. This one is the null is true. And this one is the null is false. And I'm going to go ahead and fill in the last one because I just remember that one so easy because of the two F's. So null is false, but we fail to reject it. Okay. Do you remember how to fill them in without having to look at mine? The null is true, and we fail to reject it. Yep. Because that's a good thing, right? And then this one, the null is false, and we reject it. Then this one, the null is true, but sadly we reject it. So on this side of it, it's true, false, and on this side it's fail on the outsides, reject on the insides, right? And I really think it's worth taking that time to write those, because look how easy it was on the last one for us to just go in and fill them in, right? So shouldn't it be the same kind of deal on this one? All right. So the null is true. What was the null? Well, there you go. It's very simple. The party is a dud. But we failed to reject that, which is good, right? So if we know that it's a dud, we didn't reject that, we failed to reject it, what are we going to decide? Are we going to attend or not? No, so we did not go. The party is a dud. We failed to reject that statement, which means we didn't disprove it, so we're not going to go. Okay, on this one, the null is false. So if the null is false, the party is a great time, or will be a great time. Because we rejected the null, right? It's false. It's not true. And we reject it, so the party will be a great time. So if we reject the fact that it's a dud, what does that mean? Yeah, we went. So we did go. So the party's a dud, we didn't go. The party is a great time, and we did go. Those are two good situations, right? Okay. The other two, though, the null is true, so the party is a dud, but we rejected that, so what does that mean? But we went. Wah, wah. And on this one, the null is false, so the party will be a great time. Is not a dud, same difference. Will be a great time, But we reject or we failed to reject, rather. So we didn't go. Okay. How does I have a typo, apologize. Sorry, y'all. How does the type 2 error in the party example represent a lost opportunity? Yeah, so you missed a great time, right? But then first block we're discussing, which of those would be worse, do you think? The type 1 or the type 2? Yeah, type 1. In this case, yes. Right? It's a dud, but you went, versus it was a great time, you didn't go. Maybe you went to somebody else's party, or maybe you stayed home and had a great time. You know what I mean? So yeah, in this instance, definitely think type 1 would be worse. Okay? Any questions? So what is alpha called? It's called the level of significance. If I ever say state the level of significance, I'm talking about alpha. Okay? and that is the probability of committing a type 1 error. You are going to use alpha for the rest of the year. So you need to understand it's the probability of committing a type 1 error, right? And it is just alpha. So if I give you the level of confidence, you can find alpha, right? You've been doing that. Okay. It's called the power of a test. That's 1 minus beta, and that is the probability of correctly rejecting the null. What was beta? Do you remember? It was on a slide before this, and we're going to write it out. That way you'll understand the power of a test. What was beta? Beta is the probability of committing, yep, good, a type 2 error. And then a test statistic is a random variable whose value is calculated from the sample data and then is used in making the decision to fail to reject the null or to reject the null. Y'all, you already know that. Remember, I gave examples of a statistic versus a parameter. Remember that? Statistic goes with sample. Remember S with S? And parameter goes with population. So do you remember some examples of a statistic that we could find? Like X bar, right? And if you find X bar, then you're making estimates about what? Mu, very good. If you find S, and S is your point estimate, you're making predictions about sigma. I saw you doing it with your hand. Yes, sigma. That's standard deviation, right? So last variance, so S squared goes with sigma squared. Okay? So same thing in here. Test statistic. It's just we're going to use it now in our hypothesis testing, okay? Conclusions. I call this part right here, you have to write it first. And I told you a while ago what that's called. Remember what I called that? The decision. And you always write it first. Always written first, okay? So always write your decision, which is reject or fail to reject, okay? And do you notice who we reject or fail to reject? The null, okay? And then this piece is what I call the conclusion, the sentence, okay? So the first part, reject or fail to reject, I call that the decision. And then whatever sentence we write, that's what I call the conclusion, okay? And your conclusion says there is significant evidence at the, and then you actually fill this in. So you would put 0.05 level of significance or 0.01 or whatever alpha is. You actually plug that in, okay? So you would say there is significant evidence at the 0.05 level of significance to show that, and then you write whatever the alternative hypothesis is. Oh, I'm sorry, I forgot y'all have to write all this in. Let me give you a minute. All right, so just to review with you, the first saying we call the decision, and it's always about the null, okay? So you always write about the null. Either you reject it or you fail to reject it. The second thing, which I call the conclusion, is about the alternative, okay? So your first thing, you're going to say reject the null or fail to reject. Then your next one will say either there is significant evidence at the, and you just fill that in, level of significance to show that, or there is not sufficient evidence at the blah, blah, blah level of significance to show that, and then you write the alternative hypothesis. So if I say state the decision and conclusion, decision is one of those, conclusion is one of these, but you fill in the alpha and the alternative at the end. Okay? Any questions? No? All right. A couple more things and we're done. Making a decision. Our hopes are to make the correct decision, but all we can do is try to control the probability with which the error occurs. There's always room for an error, right? So the most frequently used probability values for alpha and beta are 0.01 and 0.05. We try to keep those as small as possible because that's our probability of making the error, right? And that makes our level of confidence bigger, right? Because if alpha is 0.01, then our level of confidence is what? So they go hand in hand, okay? And then this one, it would be 95%. To complete a hypothesis test, you write a conclusion that describes the meaning of the decision relative to the meaning of the hypothesis test. So, 1, write your decision about the null, and then 2, write your conclusion using your level of significance and your alternative, okay? We're not going to do this page. Put a big X on it. The one that I just deleted. The one right after that one, because y'all did that for homework. Look at them. You did them already, right? Okay. And then another thing, that shouldn't be an A. I'm telling y'all, I got some typos up in here. Oh well. A supplier of highway materials claims he can supply an asphalt mixture that will make roads paved with his materials less slippery when wet. A general contractor who builds roads wishes to test the supplier's claim. So the null hypothesis is the roads paved with this asphalt mixture are no less slippery than the roads that are paved with other asphalt. And the alternative is roads paved with this asphalt mixture are less slippery than roads paved with other asphalt. So describe the meaning of the two possible types of errors. So we're just going to write that's not the type A and type B. We're literally just talking about the errors, okay? So error is type 1 and then type 2. I write type 2 first because I think it's easier. So the null is, help me, the null is false, and we failed to reject. And that would mean that this is, the null is true, but we reject. And now we just have to put it in words. The null is true. Where is that? The null. Roads paved with this asphalt mixture are no less slippery than roads paved with other asphalt. So, roads paved with the mixture are no less slippery. But we reject that, so what would we decide? Yeah. I guess I should put the contractor because that's who's testing it. The contractor decides that it is less slippery, right? The mixture really isn't doing anything. They're no less slippery, but the contractor decides that it is less slippery, right? He rejects the null. Do you understand that? So he's going to say that this right here, this no less slippery, he's rejecting it. So he's saying that's not true. So he's going with this, which would be that they are less slippery, okay? Does that help you? When I think of reject in my brain, I'm like, rejected. I cross it out. It's done. Okay? You all right over there? Tired? You? When I said rejected, you were like, kind of jumped. Okay. The null is false. The null is false, meaning the roads paved with the mixture what? Yep. They are less slippery. Okay. But the contractor decides what? Yeah, he's going to decide it is no less slippery. It's weird because the wording of less, no less, I know, but you're just saying the roads really are less slippery, but he's going to decide that they're not, so he's probably not going to buy the mixture. That's what that means. Okay. So which of these do you think would be worse? The roads paved with a mixture aren't any less slippery, but the contractor decides it is less slippery, so he's probably going to buy it, right? Versus this one, the roads with a mixture really are less slippery, but he decides that they're not less slippery. So he's not going to buy it. Which one do you think would be worse? You think one's worse? Because they're not less slippery, but he's going to spend the money and buy it? Spend more? All of you think that one's worse? Then two, where it is a little less slippery, but he decides it's not, so he doesn't buy it. So y'all all think type 1's worse? Interesting. Okay. I think it depends. Like if I'm the contractor, clearly I would think type 1's worse, right? But if I'm someone driving on the roads and I want it to be less slippery when they're wet and to be safer, well, then type 2's worse, right? Because they have a chance to make it safer, but he's going to decide it's not less slippery, so he's not going to purchase it. That's why I hesitate to always say type 1's always worse. I think it depends on who you are and what you're doing. So that's why I think it's good for you to always read it. All right, let me write something, because when I first saw these, I was like, how in the world are you supposed to know? So suppose alpha is assigned the following values. What is implied about the type 1 error? The more serious the error, the less willing we are to have it occur, and therefore a smaller, I don't know why I put a comma there, excuse me, and therefore a smaller probability will be assigned. Do you understand what that's saying to you? The more serious the error, the less we are willing to have it occur, so the smaller the probability we're going to assign. Okay? So if you look at these three, which one's the smallest? A. So if that's super small, then we're less willing to have it occur, right? So what does that tell me about the type 1 error? What's implied? It's very serious. Very good. Okay. So then this one would be less serious, right? So we'll call that somewhat serious. And then this last one, the 0.1. It's not really, right? So we'll just say not at all serious. And that right there is why we use these smaller values, 0.01 or 0.05 or 0.001, right? That's really super close to 100%, right? So we'd want to be 100% confident. But we can't be, there's always going to be a room for error, sadly. So you have to just use the smallest you can, all right? All right, beta has the same kind of rules. So what is implied about the type 2 error if it's 0.001? Yeah, that one as well would be very serious. This one, somewhat serious. And the last one, not at all. We're not really concerned about it. Okay? Now, when you set up your own test, you state alpha. So if you're working with something that's kind of important, serious, you want to make it as small as possible, okay? And then you can just put a big X on this one. We're not going to go through that. And you can have the rest of the time to work on your homework, okay?